Welcome, friends. I'm so glad you're here. Whether you're drifting towards sleep unwinding after a long day, or simply looking for a quiet companion, you've found the right place. Before we begin, I'd love to know where in the world are you listening from. Perhaps you're wrapped in a blanket sitting by a softly lit window, or resting somewhere under an open sky. Wherever you are, I hope you're warm, comfortable and ready to wander with me into the silent distances between stars. If you find peace or curiosity in these gentle stories, please consider liking the video, subscribing to the channel, or sharing it with someone who might need a moment of stillness too. And to those who've already joined along, thank you. He begins not with aliens, nor with machines, but with space itself, the patient dark that stretches between stars like an ocean without shore. The Milky Way is a barred spiral galaxy, roughly 100,000 light-years across, containing on the order of 100 billion to 400 billion stars, though even that range carries uncertainty, as counting stars through dust and distance remains an exercise in approximation. Light travels at approximately 299,792 kilometers per second, the fastest speed permitted by the structure of space-time, yet even at that pace it requires more than 4 years to cross the gulf between Earth and the nearest star system, Proxima Centauri. 4 years simply to say hello to the closest neighbour. Only a brief pause in cosmic time, only the length of a university degree, only the span of a political cycle. He lets that distance settle like dust drifting downward through still air. Most stars are far more distant than Proxima Centauri. The average separation between neighbouring stars in the Sun's region of the galaxy is about 5 light-years, but toward the galactic centre, the crowding increases, and toward the halo the stars thin into quiet isolation. The galaxy is not evenly filled. It breathes in gradients of density thick along its spiral arms, sparse in the interarm voids. Between stars lies not emptiness, but the interstellar medium, a thin mixture of hydrogen atoms, helium, trace heavier elements, cosmic rays and magnetic fields so diffuse that a cubic centimetre may contain only a single atom. A better vacuum than any laboratory on Earth could produce, and still not truly empty. He considers how a signal would travel through such medium. Radio waves moving at light speed would pass mostly unimpeded, yet their intensity would obey the inverse square law, diminishing with the square of distance. Double the distance and the signal spreads over 4 times the area. Increase the span by a factor of 1 million, and the signal weakens by 1 trillion. The mathematics are simple. The consequences are vast. A civilization might broadcast deliberately focusing energy into a tight beam, but even then across thousands of light-years the beam must remain precisely aimed at a moving target, a planet orbiting a star which itself orbits the galactic centre at roughly 220 kilometers per second. The target is not waiting. It is drifting through the galaxy like a leaf carried along a slow current. The Milky Way completes one rotation approximately every 225 to 250 million years. The Sun has circled the galaxy more than 20 times since its formation 4.6 billion years ago. In that time, continents on Earth assemble and break apart, oxygen rises and stabilizes snow, and fire alternate in cycles measured in tens of millions of years. And somewhere in that turning disk perhaps other worlds form and cool, yet the distances remain, even if intelligent life arises elsewhere, and even if it develops technology capable of producing electromagnetic signals. Those signals must traverse gulfs measured not in kilometers, but in years, multiplied into centuries into millennia. A message sent from a civilization 10,000 light-years away begins its journey before human agriculture, before written language, before the last glacial maximum ends, By the time it arrives, the senders may have transformed beyond recognition or fallen silent altogether. Only took 10 millennia. Only required the entire span of recorded human history. Only demanded that two civilizations remain technologically active at precisely overlapping intervals across cosmic time. He does not rush this thought. Overlap is a quiet constraint. The galaxy is about 13.6 billion years old. The Sun forms relatively late. Life on Earth appears perhaps by 3.5 to 3. 8 billion years ago, though the exact pathway from chemistry to biology remains a mystery still studied in laboratories and ancient rocks. Complex multicellular life emerges only in the last 600 million years. Technological civilization capable of radio transmission arises in the last century. A thin sliver of time almost invisible against geological scales. It is possible that many civilizations arise across the galaxy's history. It is also possible that their detectable phases are brief centuries or millennia before energy use shifts, signals grow quieter, or catastrophe intervenes. The Drake equation attempts to estimate the number of communicating civilizations by multiplying factors: star formation rate, fraction of stars with planets, fraction of habitable worlds, probability of life, probability of intelligence, lifetime of technological signaling. Several of these factors remain uncertain. The lifetime term in particular is unknown. He observes that even optimistic models often hinge on that final variable. If technological phases last 1 million years, the galaxy could be quietly humming. If they last only a few hundred, the silence becomes unsurprising. Only took a slight reduction in longevity. Only required that civilizations like biological species have lifespans. Only depended on the fragility of complex systems. The night sky appears crowded, yet from Earth most stars visible to the unaided eye lie within a few thousand light-years. Beyond that, dust lanes obscure optical light. Radio waves penetrate dust more easily, which is why radio astronomy becomes central to searches for extraterrestrial intelligence. Large radio telescopes scan narrow frequency bands listening for signals that stand out against natural astrophysical emissions. Hydrogen, the most abundant element in the universe, emits radiation at a wavelength of 21 centimeters due to the hyperfine transition in its ground state. Some researchers once proposed that this frequency might serve as a universal hailing channel, a natural landmark in the radio spectrum. Yet nature itself speaks there softly but persistently. The cosmic microwave background hums at 2.7 Kelvin, a relic of the early universe uniform across the sky, with tiny fluctuations that encode primordial density variations. Pulsars emit periodic radio pulses with astonishing regularity, sometimes more precise than atomic clocks. Quasars blaze across billions of light-years. The galaxy is not silent. It is simply not conversational. He lingers on the idea that even if signals exist, they may not be directed toward Earth. Communication requires intention, and intention requires knowledge of the receiver's existence. Earth has emitted detectable radio leakage for roughly 100 years. A sphere with radius 100 light-years now encloses that faint bubble of broadcast history. Within that sphere lie perhaps tens of thousands of stars, a small fraction of the Milky Way's total population. Beyond that radius, Earth remains electromagnetically anonymous. The bubble expands at light speed, but so does everything else. There is no catching up, no shortcut, only expansion into vastness, only patience measured in light-years, only the steady outward drift of a thin, weakening shell of noise. He notes quietly that even if another civilization lies 1,000 light-years away, and even if it detects Earth's radio leakage tomorrow, and even if it responds immediately, the reply would not arrive for 2,000 years. Time is not an obstacle one can negotiate. It is woven into the fabric of space itself. Special relativity permits no faster signal without violating causality. Wormholes remain hypothetical, unobserved. Warp drives remain speculative solutions to equations that demand exotic matter, with negative energy density not yet known to exist in usable form. The speed limit holds. It has held since the universe cools enough for atoms to form. It will likely hold long after the last stars fade. He allows the distances to expand once more, not in drama but in scale. The observable universe spans about 93 billion light-years in diameter, due to cosmic expansion. Yet even within a single galaxy, the silence can be explained by geometry alone. Stars are separated by so much space that if the Sun were the size of a marble, the nearest star would be another marble thousands of kilometers away. The galaxy is mostly nothing, and signals must cross that nothing. They must remain coherent. They must remain strong. They must remain timed to overlap with the listening mind. The silence then does not necessarily imply absence. It may reflect separation. It may reflect timing. It may reflect that civilizations bloom like brief lights in a forest so large that no two fireflies ever see each other glow. The image remains gentle, not dramatic, only distant. He rests there within the patient dark between stars where distance alone is enough to quiet even the brightest voice. He turns now from distance to speed, from the stretch of space to the limit written into its fabric. Light does not merely travel quickly, it travels as quickly as anything can. In vacuum it moves at 299,792 kilometers per second, and this value is not simply measured but defined, fixed within the international system of units as a constant of nature. Nothing carrying information can exceed it. This constraint is not technological but structural, arising from the geometry of spacetime described by special relativity. As velocity approaches light speed, time dilates and length contract. Relative to an external observer, energy requirements increase without bound, and causality remains protected. The limit holds without exception in every experiment conducted so far. Only took a century of physics to accept it. Only required rewriting intuition. Only demanded that common sense yield to equations. He lets the idea settle gently. Even if a civilization wishes to speak across the stars, its words must ride upon light or something slower. The galaxy, already vast, becomes larger when speed is finite. A signal crossing 1,000 light-years is not merely distant, it is 1,000 years old upon arrival. The sender speaks from a past that may no longer exist. Astronomy is always archaeology. Telescopes do not see objects as they are, but as they were. The Andromeda galaxy appears as it shone 2.5 million years ago. Distant quasars reveal conditions when the universe is young. Even the Sun is seen 8 minutes in the past. Communication across such delays becomes less a conversation and more a slow exchange of historical artifacts. A greeting becomes a fossil before it is received. He considers how expansion deepens the difficulty. The universe has been expanding since the hot, dense early state often called the Big Bang. Observations of distant galaxies show that their light is redshifted, stretched to longer wavelengths as space itself expands. This expansion is described by the metric of general relativity, not as objects moving through space, but as space expanding between objects. On the larger scales, galaxies recede from one another with velocities proportional to their distance expressed through the Hubble-Lemaitre law. The present expansion rate is approximately 70 kilometers per second per megaparsec, though measurements vary slightly depending on method and a modest tension remains between early universe and late universe determinations. The exact value is still refined. The fact of expansion is not in dispute. Only the decimals continue to shift. Only the second significant figure resists stillness. Only the cosmos keeps its footnotes open. He observes that beyond a certain distance galaxies recede faster than light due to the expansion of space itself. This does not violate relativity because it is not motion through space, but the growth of space. There exists a cosmic event horizon, a boundary beyond which events occurring now will never be observable in the future. Light emitted today from sufficiently distant regions will never reach Earth no matter how long one waits. The accelerating expansion attributed to dark energy ensures this horizon persists. Dark energy itself remains mysterious in nature, often modelled as a cosmological constant yet not directly understood. It accounts for roughly 68% of the total energy density of the universe, inferred from supernova observations and cosmic microwave background measurements. Its origin remains uncertain, a quiet placeholder in the equations, a term that fits the data, a cause still unnamed. He does not dramatize this ignorance, he lets it breathe. If civilizations arise in galaxies beyond this event horizon, their signals will never arrive. Not late, not faint, simply never. Even within our own galaxy, expansion is negligible compared to gravitational binding, yet the broader cosmic context matters. The Milky Way and Andromeda are gravitationally bound and will merge in several billion years, but more distant galaxies drift away. In trillions of years, observers in the merged remnant may see only their own galactic structure, the rest having faded beyond detection. Cosmology suggests that the window for observing the broader universe is itself temporary. Only took billions of years for stars to form. Only allowed a few tens of billions for observers to notice. Only granted a narrow era for cosmic awareness. He reflects on travel as well as signals. If one imagines physical voyages between stars, propulsion must contend with the same speed limit. Even at 10% of light speed, a journey to a star 100 light-years away would require 1,000 years, ignoring acceleration phases. Generation ships become theoretical necessities. Energy demands escalate steeply as velocity increases. The kinetic energy of an object grows with the Lorentz factor approaching infinity, as velocity approaches light speed. No known material structure can survive arbitrarily close to that limit without extraordinary engineering. Interstellar travel remains conceivable in principle at sublight speeds, yet slow on civilizational timescales. Slow enough that societies might transform between departure and arrival. Slow enough that intent may evaporate. He notes softly that communication does not require travel, yet travel might be more forgiving than waiting thousands of years for a reply. A probe sent once may carry data without expectation of response. Still, even probes must cross the same distances, enduring interstellar dust grains that at high velocities strike with significant energy. A single grain at relativistic speeds can release destructive force. Space is sparse but not perfectly empty. He allows the mathematics to soften into imagery. Light leaves a transmitter and expands outward as a sphere. The surface area of that sphere grows as 4 pi r squared. Intensity thins accordingly. Receivers must possess sufficient sensitivity and collecting area to distinguish signal from noise. Radio telescopes like those used in SETI surveys scan narrow frequency bands searching for non-random patterns. Yet scanning the entire sky across all plausible frequencies continuously is technologically demanding. One must choose where to look and when. Civilizations may broadcast at times not coinciding with observation. Only took a missed window. Only required pointing slightly elsewhere. Only depended on patience shorter than the cosmos. He returns to time dilation briefly, not as escape but as nuance. For travelers moving near light speed, subjective time slows relative to stationary observers. A journey spanning centuries externally might feel shorter aboard a relativistic craft. Yet communication between stationary planets does not benefit from such contraction. Signals propagate at sea regardless of the sender's motion. The limit remains impartial. He considers the Sun's orbit once more around the galactic centre. In the time a signal crosses 10,000 light-years, the Sun itself moves significantly along its orbit. Stars do not hold fixed positions in a static map. Galactic dynamics reshuffle neighbourhoods slowly but steadily. A civilization attempting to aim a tight beam must predict future positions centuries in advance. Stellar proper motions are measurable, yet uncertainties accumulate over long spans. The galaxy is not chaotic on short timescales, but neither is it frozen. It drifts like a slow tide of gravity. He reflects that the speed of light once thought perhaps surmountable has withstood every test. Quantum entanglement exhibits correlations that appear instantaneous, yet cannot transmit usable information faster than light. Experiments confirm that no signal rides those correlations in violation of causality. Physics guards its boundaries carefully, only teased with paradox, only offered correlation without communication, only hinted at shortcuts that close upon inspection. Thus the silence may arise not from absence of neighbours, but from the architecture of space-time. Distance stretches signals thin. Finite speed ages them into relics. Expansion removes some regions forever. And technological lifetimes still unknown must align across centuries separated by light years. He rests within this constraint, neither hopeful nor despairing, simply attentive to scale. The universe does not forbid life. It does not forbid intelligence. It does not forbid curiosity. It simply enforces patience measured in light, and light, unwavering and finite, sets the rhythm of all possible exchange. He remains within the geometry of distance and speed, but now turns gently toward time not as travel but as duration. A civilization is not merely a point in space, it is an interval. On Earth, Homo sapiens emerges roughly 300,000 years ago, agriculture arises about 12,000 years ago, and radio transmission begins scarcely more than a century ago. The span during which Earth leaks detectable electromagnetic signals into space is vanishingly thin compared to the age of the planet 4.54 billion years, and thinner still against the age of the Milky Way. If another world hosts intelligent life, its technological phase may also occupy a narrow band of time. Overlap becomes the quiet requirement. Two distant species must not only exist, they must exist simultaneously and in compatible technological states. Only took a few centuries of broadcasting, only required surviving industrialization, only depended on maintaining curiosity longer than conflict. He considers the Drake equation again not as speculation, but as structure. Several terms have grown less uncertain in recent decades. Observations from missions such as Kepler indicate that planets are common. Many stars host planetary systems, and small rocky worlds within habitable zones appear neither rare nor ubiquitous but frequent enough to invite attention. Estimates suggest that perhaps 1 in 5 Sun-like stars may host an Earth-sized planet in a temperate orbit, though definitions of Earth-like vary. The fraction of stars with planets once unknown is now close to unity. This is progress. Yet the equation's final term, the average lifetime of a detectable civilization, remains unconstrained by observation. Earth provides a single data point, and that point is still in progress. The technological phase could last millennia. It could contract abruptly. It could evolve into quieter forms that no longer radiate broadly into space. He observes that early radio and television broadcasts were relatively omnidirectional and powerful, spilling outward inefficiently. Modern communication increasingly uses fiber optics, tightly directed microwave links, and low-power digital signals. Leakage decreases as efficiency improves. A planet may grow quieter, even as it becomes more connected internally. Only took better engineering. Only required narrower beams. Only rewarded efficiency with invisibility. A civilization may not intend to hide. It may simply optimize. He lingers on biological time. On Earth, complex multicellular life appears after billions of years dominated by microbes. The Great Oxygenation Event around 2.4 billion years ago transforms the atmosphere, enabling aerobic metabolism, but also driving mass extinctions among anaerobic organisms. Evolution is not linear ascent, but branching experimentation. Intelligence, as expressed by tool use and abstract reasoning, arises in one lineage among many. Dinosaurs dominate terrestrial ecosystems for over 160 million years without producing radio telescopes. Mammals diversify after a mass extinction event 66 million years ago. Intelligence is possible, but not guaranteed. Even if life is common, technological intelligence may be rare or transient. He doesn't dramatize rarity. He lets it rest as possibility. The fossil record itself is incomplete. Soft-bodied organisms leave few traces. Entire ecosystems vanish without preservation. Deep time erases details. Plate tectonics recycles cross-subducting oceanic plates and metamorphosing continental margins. The oldest intact rocks on Earth are about 4 billion years old, and even these are altered. If a previous technological species had arisen on Earth hundreds of millions of years ago, much of its evidence might not survive to the present. This notion remains speculative, yet it illustrates how geology can obscure history. Only took subduction zones, only required erosion and metamorphism, only needed patience measured in millions of years. He considers extinction as filter. Earth has experienced at least 5 major mass extinction events, each eliminating a large fraction of species. The Permian-Triassic extinction around 252 million years ago removes approximately 90% of marine species likely driven by massive volcanic eruptions, climate change and ocean anoxia. The Cretaceous to Paleogene extinction follows an asteroid impact near present-day Yucatan altering climate abruptly. Intelligent life evolves after these resets. Catastrophe does not preclude recovery, but it interrupts continuity. A civilization might arise and then be extinguished by impact supernova radiation, runaway climate, or self-inflicted instability. The galaxy contains hazards. Gamma-ray bursts, though rare and typically distant, can sterilize planetary surfaces within narrow beams. Nearby supernovae can increase radiation flux. The exact frequency of such sterilizing events in habitable zones remains uncertain. Models vary. Data accumulate slowly. He reflects that even absent catastrophe, civilizations may transition into forms less detectable. Energy use might shift toward efficiency and minimal waste heat. Communication might rely on neutrinos or quantum systems not easily observed at interstellar distances. Artificial intelligence could operate in low-energy substrates, preferring subterranean or orbital habitats shielded from radiation. Detectability is not synonymous with existence. Only took discretion. Only required internal focus. Only rewarded survival with quiet. He returns to overlap. Imagine 2 civilizations separated by 5,000 light-years. One broadcasts for 2,000 years before falling silent. The other begins broadcasting 3,000 years later. Their signals pass through each other's regions of space, but never during coincident technological phases. Messages cross empty receivers. The galaxy may contain many such near misses. Statistical models of the Great Filter attempt to identify stages in evolution that are improbable. Abiogenesis may be rare. The emergence of complex cells may be rare. The transition to intelligence may be rare. Or the longevity of technological societies may be rare. The location of the filter remains unknown. It may lie behind humanity or ahead. This uncertainty remains quiet, neither hopeful nor ominous. He allows a gentle analogy. Civilizations may be like mayflies emerging along a vast river. Each lives briefly relative to the river's age. Many may emerge, yet their lifespans rarely coincide. The river continues regardless. The analogy is imperfect. Galaxies are not rivers, and life is not synchronized to seasons. Still the image rests softly, only took misaligned calendars, only required independent evolution, only depended on the independence of worlds. He considers also the sociology of signaling. A civilization may choose not to broadcast widely fearing unknown risks. The debate over active CT or messaging to extraterrestrial intelligence reflects such caution. Some argue that announcing one's presence could invite danger. Others contend that any advanced civilization would already detect biosignatures such as atmospheric oxygen and methane in disequilibrium. The outcome remains debated. No empirical data yet resolve the question. Earth's transmissions continue regardless, largely unintentionally. The bubble expands. He returns to the thin slice of time represented by humanity's technological era. Industrialization spans roughly 2 centuries. Digital communication spans mere decades. Whether this phase stabilizes into sustainable equilibrium or destabilizes remains uncertain. Climate change, resource depletion, and geopolitical tension illustrate challenges. Yet humanity also demonstrates adaptability and cooperative capacity. The future lifetime term in the Drake equation remains an open variable. It may grow large, it may not. Only took a few generations to transform the atmosphere measurably. Only required fossil carbon and combustion. Only revealed that planetary systems respond. He rests with the thought that silence may be statistical rather than absolute. The galaxy's stars shine steadily. Planets orbit quietly. Life may arise in pockets, bloom briefly into awareness and recede. Signals constrained by distance and speed thin as they travel. Overlap becomes rare across scales of billions of years and tens of thousands of light years. The silence then may not be empty but asynchronous, a cosmos filled with moments that do not coincide. He allows this image to settle. Lights flicker across a vast plain, each brilliant in its own night, yet separated by intervals too long and distances too wide for mutual recognition. The darkness between them remains patient, untroubled by the brevity of illumination. He turns now from duration to interference, from the brevity of civilizations to the texture of the medium through which their signals must travel. Space is often described as silent, yet electromagnetically it is never still. The universe glows faintly at microwave wavelengths with a nearly uniform background temperature of 725 Kelvin, the residual radiation from a time roughly 380,000 years after the Big Bang, when electrons and protons combine to form neutral hydrogen and photons decouple from matter. This cosmic microwave background fills every direction, a steady whisper beneath all other signals. Its fluctuations are small, on the order of 1 part in 100,000, encoding primordial density variations that later grow into galaxies. It is not loud, but it is constant. Only took 13 billion years to cool. Only required expansion to stretch ancient light. Only left behind a hum that never fully fades. He considers also the radio emissions of stars themselves. The Sun produces bursts across the electromagnetic spectrum, especially during solar flares and coronal mass ejections. Charged particles spiral along magnetic field lines, emitting radiation through synchrotron processes. Pulsars rotating neutron stars formed from supernova remnants emit beams of radio waves with remarkable periodicity, some rotating hundreds of times per second. These signals can appear artificial in their regularity, yet they are natural, governed by extreme gravity and magnetic fields. When Jocelyn Bell Burnell first observed such pulses in 1967, they are briefly nicknamed LGM for little green men before astrophysical explanation prevails. Nature can mimic intentionality. The cosmos produces patterns without purpose. He lingers on dispersion. As radio waves travel through the interstellar medium, free electrons cause frequency-dependent delays. Lower frequency waves slow slightly more than higher frequency ones, spreading a sharp pulse across time. Astronomers correct for this dispersion measure to infer distances to pulsars. A deliberate interstellar signal would also experience such effects, requiring compensation to remain coherent. The medium is thin yet not neutral. Even sparse plasma leaves fingerprints. He notes that cosmic rays' high-energy particles accelerated by supernova shocks and other energetic events traverse the galaxy and interact with interstellar gas, generating diffuse gamma-ray emission. Background radiation exists across wavelengths: infrared from dust warmed by starlight X-rays, from accreting black holes, ultraviolet from hot young stars. The electromagnetic spectrum is a layered tapestry. To insert an artificial signal into it requires choosing a frequency where natural noise is relatively low. The so-called waterhole between the hydrogen line at 1420 MHz and the hydroxyl line near 1660 MHz has been proposed as a quiet region symbolically bracketed by components of water. Yet even there galactic emissions persist. The quiet is relative, not absolute, only took atomic transitions, only required molecular physics, only provided a narrow window within a crowded sky. He considers Earth's own contribution to noise. The planet is increasingly saturated with radio frequency interference from satellites, radar, mobile networks, and digital communications. Ground-based observatories must be located in radio-quiet zones, shielded from human transmissions. Even so, interference leaks. The search for faint extraterrestrial signals competes not only with cosmic sources, but with terrestrial technology. Ironically, as humanity becomes more advanced, it becomes a louder neighbor to itself. Only took convenience, only required global connectivity, only complicated listening by speaking incessantly. He reflects that signal detection is not merely about power, but about pattern recognition. Random noise averages out, structured signals stand out. Narrowband transmissions, especially those confined to a very small frequency range, are unlikely to be produced by natural astrophysical processes and thus are prime targets in SETI searches. Yet a sufficiently advanced civilization might use broadband spread spectrum techniques to enhance security or efficiency, rendering signals indistinguishable from noise to distant observers. Encryption, compression, and modulation schemes could appear random without prior knowledge of encoding. Detectability depends on assumptions about design. He allows a quiet analogy. A whisper in a forest may be heard if it contrasts with the wind, but if it imitates the wind's rhythm, it dissolves into the leaves. The galaxy is such a forest stirred by plasma currents and stellar winds. Only took turbulence, only required magnetism, only blurred the edge between signal and static. He considers also gravitational waves ripples in space-time, first directly detected in 2015 from merging black holes. These waves propagate at light speed, carrying information about massive accelerating bodies. In principle, a sufficiently advanced civilization could manipulate mass distributions to encode information in gravitational radiation, though the energy requirements would be immense. Natural sources dominate black hole mergers, neutron-star collisions. The signals are faint even for detectors kilometers in scale. Communication via gravitational waves remains speculative and energetically extravagant. He does not pursue it further. The more plausible channels remain electromagnetic. He turns to attenuation. Although radio waves travel largely unabsorbed across interstellar distances, certain frequencies can be absorbed by ionized regions, particularly at very low frequencies. Scattering by irregularities in the interstellar plasma can blur images and smear pulses. At higher frequencies, dust absorption becomes significant. There exists no perfectly transparent band across all conditions. Every channel bears some cost. He reflects on time variability. Stellar activity cycles alter background noise levels. Supernova remnants expand and cool. The galactic environment evolves slowly but continuously. A signal transmitted during a quiet epoch might pass through regions that later become more turbulent. Detection windows shift. The sky is not static, only took rotation and orbit, only required magnetic cycles, only ensured that silence and noise trade places gently. He returns to the listener. Large radio telescopes such as Arecibo once scanned portions of the sky with high sensitivity before its collapse in 2020. Arrays like the Allen Telescope Array and FAST in China continue targeted searches. Yet the sky contains billions of potential targets, and observing time is finite. Surveys sample slices of frequency and direction for limited durations. The parameter space of possible signals, frequency bandwidth modulation, repetition rate polarization is vast. Exploring it exhaustively would require resources far beyond current capabilities. The absence of detection so far constrains certain models, but does not eliminate possibility. Only took limited funding, only required choosing among frequencies, only left much of the sky unexamined. He rests with the recognition that the cosmos speaks constantly, but in languages shaped by physics rather than intention. Thermal radiation from dust grains warmed to tens of Kelvin glows softly in infrared. Synchrotron emission from relativistic electrons spiraling in magnetic fields fills radio maps with diffuse haze. Molecular clouds emit spectral lines from rotational transitions of carbon monoxide, and other molecules revealing cold regions where stars form. The galaxy is not quiet, it is richly expressive. Yet none of these emissions carry greetings, none encode mathematics deliberately shared. They are consequences of temperature, charge, and motion. He allows the thought that a civilization's signal must not only be strong enough to cross distance and long-lived enough to overlap, but distinct enough to rise above this natural chorus. It must persist against attenuation, dispersion, scattering, and competing emissions. It must be aimed or broad enough to intersect a listening world, and it must arrive during a moment when instruments are tuned to the right frequency. The requirements accumulate gently, not dramatically like layers of dust settling over time. Only took physics, only required plasma and radiation, only layered complexity upon silence. He lets the background hum remain steady and impartial. The search continues across dishes and arrays, algorithms filtering noise from pattern. Yet the galaxy's electromagnetic ocean is deep, textured, and indifferent. A signal may cross it unseen or may never be sent, and so the silence persists not as emptiness but as a field of natural voices within which no intentional call has yet clearly emerged. He shifts gently from signals in transit to the thin membranes that surround worlds, those fragile atmospheres. that both reveal and conceal the presence of life. From a distance of light years, a planet is not seen as continents or oceans, but as a point of light whose brightness and spectrum vary subtly as it orbits its star. When a planet passes in front of its star from the observer's perspective, a small fraction of starlight filters through the planet's atmosphere. Molecules absorb specific wavelengths, imprinting dark lines upon the spectrum. This technique, transmission spectroscopy, has already revealed water vapor, carbon dioxide, methane, and other gases in exoplanet atmospheres. It is a remarkable achievement, only took precise photometry, only required measuring dips of less than 1%, only demanded patience across repeated transits. He reflects that certain combinations of gases may indicate biological activity. On Earth, the coexistence of abundant oxygen and methane is chemically unstable. Without continuous replenishment by life, these gases would react and diminish. Their simultaneous presence represents a state of disequilibrium. Atmospheric disequilibrium has been proposed as a biosignature, a remote hint that metabolism operates somewhere below the clouds. Yet interpreting such signatures is complex. Abiotic processes can sometimes mimic biological ones. Ultraviolet radiation can split water molecules, allowing hydrogen to escape and leaving oxygen behind without life. Volcanism can release methane. The context of planetary geology and stellar radiation must be considered. The line between living and non-living chemistry is not always sharply drawn from afar. Only took photochemistry, only required stellar flares, only blurred the distinction between breath and reaction. He considers that Earth itself has not always displayed the same atmospheric signals. For nearly half its history, oxygen is scarce. The Archean atmosphere likely contains methane and carbon dioxide with little free oxygen. An observer watching Earth 2.5 billion years ago might not infer complex life from spectral lines. The Great Oxygenation Event alters that picture, but even then oxygen levels fluctuate for hundreds of millions of years. Detectability changes with time. A living world may appear inert during certain epochs, only took microbial metabolisms, only required iron oxidation in ancient oceans, only transformed sky color gradually. He lingers on the faintness of technosignatures. Beyond biosignatures, researchers consider whether industrial pollutants, artificial illumination, or waste heat might betray advanced civilizations. Chlorofluorocarbons, for example, have no known large-scale natural sources and could in principle be detectable in an exoplanet atmosphere with sufficiently sensitive instruments. Yet their concentrations on Earth are measured in parts per trillion. Detecting such subtle traces across dozens or hundreds of light years would require telescopes far larger than those currently operational. Planned observatories may improve sensitivity, but practical limits remain. Artificial night-side illumination might alter a planet's light curve slightly, though distinguishing it from natural albedo variations is challenging. Waste heat from large-scale energy use could shift infrared emission. Yet again, the signal would be subtle. Only took industrial chemistry, only required refrigeration and aerosols, only produced traces that dissipate slowly. He reflects that atmospheres also conceal. Thick cloud decks like those of Venus obscure surface conditions entirely. Venus and Earth are similar in size and composition, yet their climatic histories diverge dramatically. Venus undergoes a runaway greenhouse effect, its surface temperature exceeding 460 degrees Celsius, its atmosphere dominated by carbon dioxide with sulfuric acid clouds. An observer studying Venus might detect greenhouse gases, but not infer the specific path that led there. Earth avoids such runaway through complex feedbacks involving oceans, plate tectonics, and the carbonate-silicate cycle, which regulates carbon dioxide over geological timescales. These feedbacks are subtle and not directly visible from afar. He notes that even within our own solar system, understanding atmospheric history requires spacecraft and landers. Remote spectra provide clues, but context demands in situ measurement. Exoplanets, by contrast, remain points of light. He contemplates tidally locked planets, orbiting red dwarf stars where one hemisphere faces perpetual daylight and the other eternal night. Climate models suggest that thick atmospheres or oceans could redistribute heat, preventing atmospheric collapse on the dark side. Yet red dwarfs often exhibit strong stellar flares emitting ultraviolet and X-ray radiation that can erode atmospheres over time. The long-term retention of atmospheres around such stars remains an area of active research. Some worlds may lose their gaseous envelopes before life has time to develop complexity. Only took stellar youth, only required magnetic vulnerability, only stripped skies atom by atom. He allows a gentle analogy. An atmosphere is like a whispering veil around a planet thin relative to planetary radius, yet decisive for climate and chemistry. Earth's atmosphere, if scaled to the size of an apple, would be thinner than its skin. That delicate layer moderates temperature shields from radiation and enables liquid water. Remove it, and the surface changes profoundly. Mars once possessed a thicker atmosphere and liquid water, as evidenced by ancient river valleys and mineral deposits. Over billions of years, solar wind and lower gravity contribute to atmospheric loss. Mars becomes colder and drier. A living planet can become quiet. Only took weak gravity. Only required time and solar wind. Only left behind dust and ice. He reflects on observational bias. Current exoplanet detection methods favor large planets close to their stars because they produce stronger transit signals or larger radial velocity shifts. Smaller Earth-like planets in wide orbits are harder to detect and characterize. Thus, the catalogue of known exoplanets is not a complete census, but a sample shaped by instrumentation. The apparent distribution of planetary types may shift as technology improves. Silence in current data does not equal absence. It may reflect sensitivity limits. He considers that a civilization might intentionally mask atmospheric signatures, perhaps through geoengineering or deliberate regulation of emissions. Yet such speculation remains secondary to the broader constraint even identifying life at all across interstellar distances is difficult. Biosignatures may be ambiguous, technosignatures, faint atmospheres variable across epochs. A planet may teem with microbial life and still appear spectrally ordinary. Only took metabolic subtlety, only required microscopic scale, only hid abundance beneath clouds. He rests with the recognition that atmospheres are both beacons and barriers. They carry chemical stories of planetary history, yet those stories require careful interpretation. They change over time, responding to geology, biology, and stellar influence. From afar they are read through narrow spectral windows filtered through instrumental noise and cosmic distance. The search for life beyond Earth increasingly focuses on these thin shells of gas, scanning for imbalance, for unexpected combinations, for traces of industry. Yet each potential sign demands caution. False positives and false negatives both linger as possibilities. The cosmos may host many living worlds whose atmospheres do not advertise their vitality in obvious ways, or it may host few. The data continue to accumulate slowly, photon by photon. Meanwhile, Earth's own atmosphere drifts outward into space molecule by molecule at the exosphere, while below chemistry cycles in complex loops. A thin veil sustaining thought, sending faint signals outward and revealing itself only to those who look with patience across impossible distances. He now turns from atmospheres to the worlds beneath them, to the slow assembly of planets, and the narrow corridors within which stability endures. Stars form from collapsing molecular clouds, dense knots within vast regions of cold hydrogen and dust. As gravity draws material inward, angular momentum flattens the infalling gas into a rotating protoplanetary disk. Within that disk, microscopic grains collide and adhere through electrostatic forces, forming aggregates that grow into planetesimals kilometers across. Over hundreds of thousands to millions of years, these bodies collide and merge, sometimes shattering, sometimes accreting, gradually building planetary embryos. This process, core accretion, is widely accepted as the dominant mechanism for forming terrestrial planets. Gas giants likely form more rapidly, capturing thick envelopes of hydrogen and helium before the disk disperses. The disk itself dissipates within a few million years, sculpted by stellar winds and radiation. Only took dust, only required gravity's patience, only needed collisions repeated without intention. He lingers on the early violence of planetary systems. During the late stages of accretion, gravitational interactions among embryos lead to chaotic orbits and frequent impacts. Earth's moon likely forms from a collision between the proto-Earth and a Mars-sized body often called Theia approximately 4.5 billion years ago. The impact ejects material that coalesces into the moon, altering Earth's rotation and axial tilt. This event influences tides, stabilizes obliquity over long timescales, and may affect climate stability. The exact details of the impact remain refined through isotopic studies and simulations, yet the broad scenario holds consensus. Only took one collision, only required enough angular momentum, only left behind a companion that shapes tides quietly for billions of years. He considers orbital stability. A planet must reside within a star's habitable zone for liquid water to persist at the surface, assuming suitable atmospheric pressure. Yet habitability is not determined by distance alone. Orbital eccentricity influences seasonal extremes. High eccentricity can lead to temperature swings that challenge stable climates. Gravitational perturbations from giant planets can destabilize smaller worlds, ejecting them from the system or inducing high inclinations. In some systems, hot Jupiters migrate inward, early disrupting inner terrestrial planet formation. Observations reveal that planetary architectures vary widely. Our solar system's relatively circular, well-spaced orbits may not be universal. Only took migration through the disk, only required resonance and torque, only reshaped systems before life has time to begin. He reflects on stellar type. Massive stars burn brightly but briefly exhausting nuclear fuel within millions of years, too short for complex life to evolve by Earth-like timescales. Low-mass red dwarfs can persist for trillions of years, offering extended stability, yet their early active phases may subject close-in planets to intense flaring and radiation. Sun-like stars occupy a middle ground with lifetimes of about 10 billion years. Earth forms roughly 4.6 billion years ago, leaving billions more years before the Sun's gradual brightening renders the planet uninhabitable. Stellar luminosity increases slowly over time as hydrogen fuses into helium in the core, altering energy output. Climate must adjust through feedbacks. Only took steady fusion, only required hydrogen compression, only ensured that even stable stars evolve. He turns to plate tectonics, a process that may be crucial for long-term climate regulation. On Earth, the movement of lithospheric plates recycles carbon between the surface and interior through subduction and volcanic outgassing. The carbonate-silicate cycle acts as a thermostat over geological timescales, drawing down carbon dioxide when temperatures rise and releasing it when temperatures fall. This negative feedback stabilizes climate within bounds conducive to liquid water. Whether plate tectonics is common among rocky exoplanets remains uncertain. It may depend on planetary mass internal heat budget and presence of water to lubricate subduction zones. A stagnant lid planet lacking plate tectonics might accumulate atmospheric carbon dioxide without efficient recycling, risking runaway greenhouse or deep freeze. Only took mantle convection, only required radiogenic heating, only allowed continents to drift slowly like patient rafts. He reflects on magnetic fields. Earth's geodynamo, driven by convection in the liquid outer core, generates a magnetic field that shields the atmosphere from direct solar wind stripping. Mars, smaller and cooling more rapidly, loses its global magnetic field early in its history. Without sustained shielding, its atmosphere thins. A planet's size influences heat retention. Too small an internal dynamo activity ceases quickly. Too large and high pressure may alter mantle dynamics in ways not yet fully understood. The precise mass range favourable for long-term habitability remains a topic of modelling and debate. Only took ion convection. Only required rotation and heat flow. Only stood between air and erosion. He considers water delivery. Earth's water may originate from volatile-rich planetesimals or comets from beyond the snowline where ices are stable. Isotopic ratios of hydrogen in Earth's oceans resemble those of certain carbonaceous chondrite meteorites, suggesting asteroidal contribution. The timing and mechanism of water delivery remain areas of active research. Without sufficient water, plate tectonics and surface chemistry differ markedly. Yet too much water could create a global ocean world lacking exposed land for silicate weathering, altering carbon cycling. Habitability may occupy a narrow band not only of distance but of composition. Only took icy fragments. Only required inward scattering. Only filled basins carved by cooling crust. He allows a gentle analogy. A planetary system is like a mobile suspended from a ceiling, each component influencing the others through gravity's threads. Slight adjustments alter balance. Some configurations remain steady for billions of years, others wobble and collapse. The search for life assumes that stability persists long enough for biology to unfold. Yet many systems may not maintain such equilibrium. Dynamical simulations reveal instabilities emerging over millions or billions of years, leading to collisions or ejections. The solar system itself exhibits chaotic elements over long timescales, though broadly stable within current projections. Only took minor perturbations. Only required resonance overlap. Only hinted that permanence is statistical, not absolute. He reflects that even if stable worlds are not exceedingly rare, the combination of factors, appropriate stellar-type orbital distance, low eccentricity, presence of water, sustained magnetic field, active geology narrows the field. Each requirement is grounded in physical processes observed within our solar system. None demand miracle, all demand alignment. The universe contains vast numbers of stars, yet vastness does not guarantee that complex stability is common. It only provides opportunity. Whether opportunity is frequently realized remains under investigation. He rests within the image of disks condensing into worlds of impacts, forging moons of tectonic plates gliding over mantle currents of magnetic fields, arching invisibly into space. These processes unfold without intention, governed by gravity, thermodynamics, and nuclear fusion. A world suitable for long-lived life must navigate these constraints quietly and continuously. If such worlds are uncommon, then civilizations are correspondingly sparse. If they are common, distance and time still intervene. The silence may thus begin not in absence of intelligence, but in the rarity of enduring platforms upon which intelligence can persist. Planets must first be patient before minds can be brief. He now lowers his gaze further beneath crust and ocean, into the slower chemistry that precedes intelligence by billions of years. Even on a stable world with liquid water, a temperate orbit and a protective magnetic field, life does not appear instantly. Earth forms about 4.54 billion years ago. For tens of millions of years its surface remains molten, in places reshaped by impacts during the late heavy bombardment. Yet zircon crystals dated to roughly 4 billion years suggest that liquid water may already exist on the surface surprisingly early. The precise timeline remains debated, but by at least 3.5 billion years ago, and possibly earlier, microbial life is present, evidenced by stromatolites and isotopic signatures consistent with biological carbon fixation. The transition from non-living chemistry to self-replicating systems of biogenesis remains unresolved in detail. Several hypotheses exist, RNA world scenarios in which ribonucleic acid acts both as genetic material and catalyst. Metabolism, first models emphasizing self-sustaining chemical cycles. Hydrothermal vent environments providing mineral surfaces and energy gradients. No single pathway has been conclusively demonstrated. Only took chemistry. Only required gradients in temperature and pH. Only left questions that laboratories still approach carefully. He reflects that even once simple life emerges, complexity does not follow quickly. For nearly 2 billion years, Earth is dominated by single-celled organisms. Photosynthetic cyanobacteria gradually release oxygen as a byproduct, but oxygen accumulates in the atmosphere only after geological sinks iron in oceans and volcanic gases become saturated. The Great Oxygenation Event around 4 billion years ago represents a planetary transformation, yet multicellular life remains microscopic for long afterward. The evolution of eukaryotic cells containing membrane-bound organelles and a nucleus likely involves an endosymbiotic event in which one cell engulfs another that becomes the mitochondrion. This symbiosis allows more efficient energy production, enabling greater cellular complexity. The exact sequence and frequency of such events elsewhere remain unknown. Only took one merger. Only required cooperation between former competitors. Only expanded metabolic possibility quietly. He lingers on energy as constraint. Life requires free energy to maintain order against entropy. On Earth, sunlight provides the primary energy source for most ecosystems captured through photosynthesis. In deep ocean hydrothermal vents, chemosynthetic organisms harness chemical gradients instead. Energy availability shapes biological potential. A planet orbiting a dim star may receive limited flux constraining productivity. Alternatively, thick cloud cover may reduce surface insulation. Tidal heating as observed on Jupiter's moon, Europa and Saturn's moon, Enceladus, can provide internal energy for subsurface oceans, yet such environments may be isolated beneath ice shells tens of kilometers thick. Communication from such biospheres to space would be improbable. Only took ice crusts. Only required orbital resonance. Only sealed oceans beneath frozen silence. He considers evolutionary contingency. Stephen Jay Gould once suggests that if one were to replay the tape of life, outcomes might differ dramatically. Evolution proceeds through mutation selection, genetic drift and environmental pressures. Intelligence as expressed in humans arises along one lineage among countless possibilities. Cephalopods exhibit remarkable cognition without developing technology. Social insects demonstrate complex organization without symbolic language. The pathway to tool-building radio-emitting intelligence may not be inevitable. It may require specific ecological and anatomical circumstances, manipulative appendages, long developmental periods, social learning, environmental variability that rewards problem-solving. These conditions may be uncommon, or they may be common in ways not yet understood. The sample size remains 1, only took one branch, only required extinction of others, only produced a mind capable of asking questions late in planetary history. He reflects on time once more. From the emergence of life around 3.5 billion years ago to the appearance of anatomically modern humans spans more than 3 billion years. Complex multicellular organisms appear around 600 million years ago during the Ediacaran period. The Cambrian explosion follows diversifying body plans rapidly in geological terms, yet still across millions of years. Dinosaurs dominate for over 160 million years without developing radio astronomy. Mammals diversify after their extinction. Intelligence capable of abstract mathematics appears only recently. This sequence suggests that while life may arise relatively early under favorable conditions, technological intelligence may require prolonged stability and contingent events. Only took 3 billion years. Only required oxygenation and symbiosis, only depended on asteroid impacts and shifting climates. He contemplates planetary setbacks. Snowball Earth episodes during the Proterozoic may encase the planet in global or near-global ice reflecting sunlight and suppressing photosynthesis. Volcanic outgassing eventually accumulates greenhouse gases, melting the ice and restoring temperate conditions. Life persists through these extremes, but such events illustrate fragility. A planet might experience repeated global crises that delay or reset complexity. The frequency of such episodes elsewhere remains uncertain. Climate feedbacks depend on continental configuration, volcanic activity, and stellar luminosity. Only took albedo feedback. Only required carbon dioxide buildup. Only alternated freeze and thaw over millions of years. He considers the biochemical foundations. Life on Earth uses carbon-based molecules in aqueous solution, relying on elements such as hydrogen, oxygen, nitrogen, phosphorus, and sulfur. These elements are produced in stellar nucleosynthesis and distributed through supernova explosions. The universe's chemical evolution gradually enriches interstellar medium with heavier elements over cosmic time. Early generations of stars contain fewer metals. Later stars inherit enriched material. Thus, the probability of rocky planet formation and complex chemistry may increase as galaxies age. Humanity arises relatively late in cosmic history, roughly 9 billion years after the Milky Way forms. Some models suggest that habitability peaks at certain epochs, when metallicity is sufficient but catastrophic events less frequent. The exact temporal distribution of life-supporting conditions remains an area of modeling. Only took stellar death. Only required fusion beyond helium. Only seeded clouds with carbon and oxygen. He rests on the recognition that the pathway from chemistry to cognition is neither instantaneous nor guaranteed. It unfolds across billions of years under conditions that must remain within tolerable bounds. Even slight deviations in climate radiation or planetary composition can alter evolutionary trajectories. A world may host microbial life indefinitely without producing large brains. It may harbour complex ecosystems that never develop technology. The silence of the cosmos may therefore reflect not only distance and duration of civilizations, but the slow, uncertain climb from molecules to minds. He allows a final quiet observation even on Earth. Intelligence capable of interstellar reflection occupies a fraction of planetary time. If similar fractions apply elsewhere, then at any given moment few worlds may host such minds, not because life is impossible, but because its most communicative form is rare in both space and time. The galaxy may teem with microbes, with forests beneath alien suns, with oceans beneath ice, yet still remain quiet in radio frequencies. Chemistry can be abundant. Complexity can be patient. Awareness can be brief. And in that arithmetic of deep time silence becomes less surprising, resting not as emptiness, but as the natural interval between unlikely awakenings. He now turns from biology to sociology, from cells to civilizations, and asks not how life begins, but how it persists once it can speak across the void. Intelligence is not the final filter. Survival may be. On Earth, technological civilization occupies scarcely more than a century of detectable radio emission, and even that window may be closing as communication shifts toward fiber optics and directed signals less likely to leak into space. If another civilization followed a similar trajectory, its period of high radio luminosity might be brief decades or centuries against stellar lifetimes measured in billions of years. The probability that two civilizations overlap in both space and time and use compatible technologies narrows dramatically. Only took 100 years, only required modulation of electromagnetic waves, only produced a faint expanding shell of signals thinning with distance. He examines the concept sometimes termed the Great Filter, a hypothesized stage in cosmic evolution that is exceedingly improbable. The filter might lie behind humanity. Perhaps abiogenesis is extraordinarily rare. It might lie ahead. Perhaps advanced civilizations tend to self-destruct through warfare, ecological collapse, uncontrolled artificial intelligence, or resource depletion. Earth's record offers cautionary patterns at smaller scale societies rise and fall, often limited by environmental constraints and internal conflict. A global civilization with access to nuclear arsenals and planetary-scale industrial impact introduces risks unprecedented in earlier epochs. This same ingenuity that enables radio telescopes also enables irreversible harm, only took splitting atoms, only required fossil fuels buried in ancient strata, only amplified primate competition with planetary consequence. He considers longevity as a parameter. In the Drake equation, L represents the length of time a civilization releases detectable signals. If L is short relative to cosmic timescales, then even a galaxy filled with civilizations across history could appear empty at present. Civilizations might flicker like brief sparks separated by millions of years. Communication across tens or hundreds of light years requires not only simultaneity but patience. A message sent to a star 500 light years away demands a millennium for round-trip exchange. Any society undertaking such dialogue must maintain continuity over generational spans that challenge political and cultural stability. Only took centuries of institutional memory, only required preservation of purpose beyond individual lifetimes, only demanded faith in unseen correspondence. He reflects on alternative modes of existence. A sufficiently advanced civilization might migrate inward rather than outward, prioritizing virtual realities or energy-efficient computation over interstellar colonization. Theoretical constructs such as Dyson spheres, mega-scale structures capturing a star's energy, would alter observable signatures potentially detectable as infrared excess. Yet surveys have not identified unambiguous evidence of such engineering in the Milky Way. Perhaps megastructures are impractical. Perhaps energy efficiency encourages minimal waste heat, rendering them less conspicuous. Or perhaps advanced societies transition into forms difficult to recognize with current instruments. Only took silicon substrates. Only required algorithms surpassing biological cognition. Only redirected aspiration from expansion to introspection. He considers expansion itself. Interstellar travel poses formidable barriers, immense distances, radiation exposure, energy requirements, and the constraints of relativistic physics. Even at 10% the speed of light reaching the nearest star system would require over 40 years of travel time, not accounting for acceleration and deceleration. Self-replicating probes, sometimes termed von Neumann machines, have been proposed as a mechanism for rapid galactic colonization, spreading exponentially over millions of years, a brief interval cosmically. If such probes were feasible and common, their absence in observation becomes notable. This absence is sometimes called the Fermi paradox, named after Enrico Fermi's question, "Where is everybody?" The paradox sharpens when considering the Milky Way's age approximately 13, 6 billion years providing ample time for multiple waves of expansion. Only took exponential growth, only required replication and resource extraction, only left no visible artifacts in our surveys. He shifts perspective toward observational limits, the search for extraterrestrial intelligence coordinated through initiatives such as the SETI Institute and projects like Breakthrough Listen Scans, radio frequencies for narrow-band signals unlikely to arise from natural astrophysical processes, optical SETI searches for laser pulses. Yet the parameter space is vast frequencies, modulation schemes, time intervals, sky coverage. Humanity has sampled only a minute fraction. Declaring absence based on limited search would be premature. Technological civilizations might use communication methods not yet imagined or operate at power levels below our detection thresholds. Only took a few decades of systematic listening. Only required large radio dishes pointed patiently at stars, only covered a thin slice of possible channels. He revisits astrophysical hazards. Gamma-ray bursts, supernovae and active galactic nuclei can sterilize regions, or at least disrupt biospheres. If complex life requires long periods without nearby catastrophic events, then safe zones may be rarer than planetary counts suggest. The galactic habitable zone concept proposes that regions too close to the galactic center experience high radiation and gravitational perturbations, while outer regions may lack sufficient metallicity for rocky planets. Earth's position roughly 8 kiloparsecs from the center may represent a favorable compromise. If such zones are narrow, then the spatial density of advanced life may be limited. Only took distance from the core, only required moderate metallicity, only balanced radiation against chemistry. He considers cultural choice. Even if civilizations arise and endure, they may choose silence. Broadcasting one's presence carries unknown risk. Another civilization might be hostile or simply indifferent, but technologically superior. The debate over active SETI sending deliberate messages remains unresolved. Some argue that the galaxy's age implies that any advanced society would already know of emerging civilizations through passive observation. Others caution against assuming benign intent. Silence may be strategy rather than absence. Only took caution extrapolated to cosmic scale. Only required recognition of asymmetry. Only favoured listening over shouting. He contemplates that humanity's perception of silence may also reflect anthropocentrism. Communication need not be electromagnetic. It might occur through neutrinos' gravitational waves or engineered phenomena beyond current detection, or intelligence may manifest in distributed planetary ecologies rather than discrete technological species. The search often presumes mirrors of human development. Expanding conceptual frameworks could alter interpretation of data already collected. Only took assumptions embedded in equations. Only required language shaped by terrestrial evolution. Only constrained imagination more than reality. He returns to timescales once more, noting that the observable universe is approximately 8 billion years old, while the Sun has about 5 billion years of main sequence life remaining. If intelligent life tends to emerge late in stellar lifetimes, humanity may be early rather than late relative to the cosmic average. Future trillions of years around long-lived red dwarfs could host civilizations yet unborn. In that view, the silence is not emptiness but anticipation. The era of communicative intelligence may just be beginning, only took stellar lifetimes stretching beyond present epochs, only required patience exceeding human history, only deferred conversation to distant futures. He gathers these strands: biological contingency, technological fragility, temporal mismatch, observational limits, strategic silence. None alone resolves the paradox. Together they soften it. The absence of evidence becomes less accusatory, more provisional. The sky's quiet does not demand uniqueness. It permits rarity, brevity, distance. Humanity's telescopes extend vision but not certainty. The radio spectrum remains mostly unexplored, the galaxy mostly unvisited, the chemistry of life mostly inferred from a single example. He concludes this section without proclamation. Civilizations may rise, rarely endure, briefly choose silence, or communicate in ways unnoticed. The filter may lie behind or ahead. The galaxy may host minds separated by gulfs of time rather than space. The paradox remains a question, not a verdict, and in that unresolved space between possibility and proof, inquiry persists not as assurance of company, nor as confirmation of solitude, but as disciplined curiosity sustained against the vast patient quiet of the stars. He now widens the aperture beyond the Milky Way, not because intergalactic dialogue is plausible with present physics, but because scale reframes expectation. The observable universe contains on the order of 2 trillion galaxies each, with billions or hundreds of billions of stars. Even if the probability of technological intelligence per galaxy were vanishingly small, multiplication by such magnitude suggests that somewhere at some epoch, minds have arisen many times. Yet cosmic expansion imposes a horizon. Galaxies beyond a certain distance recede faster than light due to metric expansion, rendering causal contact forever impossible. The accelerating expansion attributed to dark energy ensures that over tens of billions of years distant galaxies will slip beyond observability entirely. Civilizations emerging in far futures may look outward and see only their local group, unaware that a richer cosmos once filled the sky, only took a cosmological constant, only required spacetime itself to stretch, only sealed vast archives of galaxies beyond reachable exchange. He considers that the search for intelligence is inseparable from cosmology. Parameters such as the amplitude of primordial density, fluctuations the ratio of baryonic matter to dark matter, and the strength of fundamental forces influence galaxy formation, star lifetimes, and chemical complexity. Slight deviations in constants could yield universes where stars burn too briefly for life to evolve, or where heavy elements never form. The anthropic principle in weak form notes that observers necessarily find themselves in conditions compatible with observation. Whether this reflects deep necessity multiverse selection, or mere tautology, remains debated. Yet the fact persists: the same constants that allow carbon synthesis in stellar cores also allow neurons to fire in reflective minds, only took resonance levels in atomic nuclei, only required gravity balanced against radiation pressure, only permitted chemistry rich enough for replication. He pauses at carbon, at the triple alpha process in which 3 helium nuclei combine to form carbon-12 within stars. Fred Hoyle predicted a specific excited state in carbon to account for observed abundances. Its experimental confirmation remains one of astrophysics' elegant validations. Without that resonance, carbon might be scarce, and life as known improbable. Such sensitivities raise the question of how common life-supporting universes might be if physical laws vary across hypothetical multiverses. This speculation remains beyond empirical confirmation, yet it underscores contingency at foundational scales. only took a resonance at 7.65 mega-electron-volts, only required stellar cores reaching sufficient temperature and density, only enabled organic chemistry across galaxies. He returns from cosmological abstraction to methodological humility. Humanity infers probabilities from one data point. Statistical reasoning falters when n equals 1. Bayesian approaches attempt to incorporate prior assumptions, yet priors themselves encode uncertainty. Some analyses suggest that early emergence of life on Earth implies high probability under suitable conditions. Others caution that observational selection bias life must arise early enough for intelligence to evolve before stellar death distorts inference. The debate remains unresolved. Only took inference under constraint, only required acknowledging selection effects, only prevented confident extrapolation from a single world. He reflects on detection strategies expanding beyond radio. Atmospheric spectroscopy of exoplanets now searches for biosignatures such as oxygen-methane and disequilibrium combinations unlikely to persist abiotically. The James Webb Space Telescope has begun characterizing atmospheres of transiting exoplanets, while future observatories aim to image Earth-like worlds directly. Yet biosignatures do not equal technosignatures. Oxygen could accumulate through non-biological processes under certain conditions. Conversely, alien biochemistries might not produce familiar gases. Interpreting spectral lines requires careful modeling of planetary context. Only took photons filtered through alien skies. Only required transit geometry aligning with telescopes. Only yielded faint absorption features across light years. He considers that intelligence may not manifest in grand engineering, but in subtle planetary stewardship. A civilization prioritizing sustainability might minimize industrial pollution, leaving little atmospheric trace. Conversely, a rapidly expanding society might generate detectable chlorofluorocarbons or artificial illumination visible on planetary night sides. Searches for city lights on exoplanets remain speculative yet conceptually possible with future instruments. The spectrum of detectability intertwines with values and choices. Only took industrial chemistry. Only required nocturnal luminosity exceeding natural albedo. Only hinted at presence through marginal excess photons. He examines the psychological dimension of the question. Human narratives oscillate between cosmic loneliness and expectation of companionship. Cultural artifacts from ancient myths to modern science fiction populate the sky with imagined others. These stories influence interpretation of silence, sometimes amplifying disappointment, sometimes deepening awe. Yet scientific inquiry demands suspension of narrative preference. The universe owes no affirmation of human desire for contact. It presents data, interpretation follows discipline. Only took myth-making primates gazing upward. Only required pattern-seeking cognition. Only coloured analysis with hope and apprehension. He reflects on communication across epistemic divides. Even if contact occurred, mutual comprehension would not be guaranteed. Mathematics is often proposed as universal language, yet even mathematical symbols require shared recognition of patterns. Physical constants, prime number sequences, spectral lines of hydrogen, these serve as potential bridges. Historical attempts such as the Arecibo message encoded information about human biology and solar system structure in binary format. Whether such encoding would be decipherable by non-human cognition remains uncertain. Only took binary grids of bits. Only required assumptions about symmetry and counting. Only entrusted meaning to shared physics. He turns to the possibility that intelligence tends towards self-limitation. Advanced civilizations might recognize risks inherent in expansion and choose equilibrium. Rather than colonizing aggressively, they may cultivate long-term planetary stability, reducing energetic signatures. Galactic colonization models often assume growth as intrinsic motivation. Yet biological evolution does not mandate cultural values. A species might prioritize contemplation over conquest. Only took cultural evolution diverging from biological drives. Only required ethical frameworks favoring restraint. Only diminished visible footprint across interstellar distances. He revisits time once more, but now through entropy. The universe's usable energy declines over cosmological epochs as stars exhaust nuclear fuel and black holes dominate mass distribution. If life requires energy gradients, then windows of habitability may narrow in far futures. Yet around red dwarfs which can burn for trillions of years, stable conditions may persist far longer than around sun-like stars. Civilizations emerging around such stars would inhabit epochs scarcely begun. Humanity may be cosmically premature, asking questions in a universe still rich with untapped potential. Only took stellar masses 1/10 of the Sun. Only required slow hydrogen fusion sustaining dim light for trillions of years. Only deferred the majority of life-bearing opportunities to distant eras. He allows the paradox to remain paradox. The silence may signify rarity, brevity, immaturity of search, strategic quiet, or simple distance beyond practical communication. It may also reflect that intelligence is common yet subtle, embedded in ecological harmony rather than megastructures. The question, where is everybody, presumes that everybody behaves recognizably. Perhaps recognition is the rarer faculty. He concludes not with resolution but with orientation. Inquiry must continue across disciplines, astronomy, biology, geology, computer, science, ethics, because the question of cosmic company intersects all. Each telescope extended, each spectrum analyzed, each model refined contributes incrementally. Silence properly understood is not negation but data awaiting context. The stars do not answer in human cadence. They answer in photons, neutrinos, gravitational ripples. Whether those signals encode intention or only natural process remains open. In that openness lies both humility and motivation. The universe is vast beyond intuitive grasp, structured by laws at once elegant and contingent, from resonant carbon nuclei to fragile civilizations contemplating expansion. A chain of improbabilities unfolds. That chain has produced at least one reflective species. Whether it has produced many others remains uncertain. The task is neither to assume solitude nor to presume abundance, but to measure, to listen, to reason without haste. Between certainty and speculation stretches a disciplined patience equal perhaps to the patience of stars themselves. He now turns inward once more, not to retreat from cosmology, but to examine the observer as instrument, because every conclusion about the universe passes through human cognition, with its limits, biases, and architectures shaped by evolutionary pressures rather than cosmic comprehension. The brain that contemplates galactic distribution evolved to track prey across savannas, to navigate social hierarchies, to detect agency in rustling grass. Hyperactive pattern recognition once conferred survival advantage. In astrophysics, it risks seeing intention where stochastic process suffices. Conversely, cognitive inertia may resist recognizing unprecedented forms of signal. Thus, the search for extraterrestrial intelligence is not only technical, but epistemological. How does a species detect what it has never encountered? Only took neurons firing through electrochemical gradients. Only required synaptic pruning shaped by ancestral environments. Only constrained cosmic interpretation within primate architecture. He considers instrumental mediation. Telescopes translate invisible wavelengths into data, arrays. Algorithms sift noise from candidate signals. Statistical thresholds determine significance. Each stage embeds assumptions. A narrow-band radio spike might be flagged as artificial yet natural astrophysical mazes can mimic coherence under certain conditions. Machine learning systems trained on known phenomena may overlook anomalous patterns outside training distributions. The unknown unknowns remain resistant to categorization. Only took silicon detectors cooled to cryogenic temperatures. Only required Fourier transforms passing frequency space. Only left room for misclassification at margins of probability. He reflects on funding cycles and institutional priorities. Large observatories demand political support. Long-term listening projects compete with immediate terrestrial concerns. Civilizations allocate attention according to perceived urgency. If the search for cosmic company lacks immediate practical benefit, it risks marginalization. Yet the question touches identity at civilizational scale. Whether humanity persists in sustained inquiry may itself influence detectability. A culture that invests in outward-looking science projects signals certain values about continuity and curiosity. Only took budget committees and grant proposals. Only required societal surplus beyond subsistence. Only determined whether dishes keep listening or fall silent. He examines communication delay not merely as physical constraint but as cultural challenge. Suppose a signal were detected from a star 200 light-years away, clearly artificial, unmistakably patterned. The initial confirmation would electrify global society, yet response would unfold across centuries. The senders, if still extant, would not hear humanity's reply for 2 centuries more. Diplomacy under such latency defies historical precedent. International coordination, message crafting, ethical deliberation, these would span generations. The meaning of reciprocity shifts when interlocutors are separated by epochs. Only took 200 years of light travel. Only required patience exceeding political cycles. Only redefined dialogue as archival transmission across time. He considers that confirmation of extraterrestrial intelligence would recalibrate philosophical frameworks. Religious traditions might reinterpret doctrines. Scientific paradigms would expand. Concepts of uniqueness would erode or transform. Yet absence of detection also shapes worldview, encouraging introspection about responsibility as potentially solitary intelligence within reachable space. Both outcomes carry weight. Only took reinterpretation of ancient texts. Only required humility before larger context. Only reframed humanity's narrative from center to participant or from participant to guardian. He reflects on risk asymmetry. If the great filter lies ahead, then humanity's trajectory becomes experiment and warning. Technologies such as synthetic biology, advanced artificial intelligence, and geoengineering introduce transformative capacity with uncertain side effects. Managing such power demands foresight and global cooperation rarely achieved historically. Perhaps many civilizations reach a threshold where capability outpaces wisdom. Survival then depends on aligning technological acceleration with ethical maturation. Only took CRISPR editing genomes. Only required neural networks surpassing narrow cognitive tasks. Only demanded governance scaling with innovation. He turns briefly to artificial intelligence as potential successor or partner in cosmic exploration. Machine systems could endure radiation, operate across millennia, with maintenance and traverse interstellar distances as probes carrying compressed archives of civilization. If biological lifespans limit continuity, synthetic agents might extend it. Yet creating autonomous systems capable of representing humanity responsibly introduces philosophical questions about identity and agency. Would such probes embody civilization or merely artifacts of it? Only took code executing on durable substrates. Only required error-correcting redundancy across centuries. only blurred line between creator and envoy. He contemplates existential perspective. Whether alone or not, humanity occupies a thin temporal slice between planetary formation and stellar red giant phase. The Sun will expand in roughly 5 billion years, rendering Earth uninhabitable. Long before that gradual brightening may disrupt climate stability, interstellar migration, if feasible, becomes not luxury but eventual necessity. The silence of the cosmos thus intersects survival planning. If others have navigated similar transitions, their absence of visible infrastructure may imply difficulty bordering on impossibility. Only took stellar evolution models predicting luminosity increase. Only required understanding hydrogen exhaustion in cores. Only imposed deadline measured in geological epochs yet finite. He revisits the emotional dimension with restraint. Awe arises naturally before images from deep field telescopes revealing thousands of galaxies in a patch of sky smaller than a grain of sand at arm's length. Such images recalibrate scale intuitively, yet awe must coexist with rigor. Vastness does not equate to abundance of life, nor does silence entail desolation. Emotional response should motivate measurement, not replace it. Only took long exposure imaging through space-based observatories, only required stacking photons across hours, only revealed structure invisible to unaided sight. He considers contingency one final time. The chain from quark confinement to conscious reflection traverses physics, chemistry, biology, culture. Break any link and the outcome diverges. That this chain holds at least once suggests compatibility between fundamental law and complexity. Whether compatibility implies inevitability remains unsettled. Statistical mechanics describes ensembles. History describes particulars. The universe provides ensemble scale. Life unfolds in particulars. Only took symmetry breaking in early universe. Only required matter slightly exceeding antimatter, only permitted galaxies to condense from fluctuations. He gathers implications cautiously. If intelligence is rare, responsibility intensifies preservation of biosphere, and culture acquires cosmic significance. If intelligence is common, yet distant humility persists. Humanity becomes one voice among many, perhaps unremarkable. If intelligence is abundant but ephemeral urgency sharpens longevity, becomes distinguishing achievement. In all scenarios, stewardship of knowledge and environment retains centrality. Only took libraries storing accumulated insight. Only required intergenerational education. Only sustained inquiry beyond individual mortality. He closes this section not with answer, but with directive orientation. Continue observing, expand parameter space of search, refine models of planetary atmospheres and stellar evolution, develop technologies with foresight regarding long-term survivability, cultivate cultural frameworks capable of patience measured in centuries. The silence encountered thus far is a beginning datum, not terminal conclusion. It invites disciplined persistence rather than speculative resignation. The role remains observer, analyst, participant in unfolding cosmic history. Always double-check the role, not prophet, not pessimist, not romantic, but careful in inference and measured in tone. Between ignorance and knowledge stretches an expanse comparable to interstellar distance. Crossing it demands incremental propulsion, powered by curiosity and restraint. The stars will not hasten response. The task is to ensure that when evidence arrives, whether signal detected or silence sustained, humanity is prepared to interpret it with clarity rather than projection. Until then, the universe remains neither crowded nor empty in certainty, only vast, structured and patient beyond immediate comprehension, awaiting further measurement from a species newly aware enough to ask, and cautious enough to know that the answer Whatever it proves to be must be earned through sustained disciplined attention, rather than presumed from longing or fear. He now allows the inquiry to move towards synthesis, not conclusion, because synthesis in cosmological matters remains provisional by necessity. The silence observed thus far across radio surveys, optical searches, infrared examinations for waste heat, atmospheric scans for industrial byproducts constitutes a dataset defined as much by its sparsity as by its scope. Absence of confirmed technosignatures across decades of systematic observation suggests constraints, yet constraints differ from negations. Parameter space remains immense. Technological pathways remain partially imagined. Evolutionary contingencies remain modelled from a single biosphere. Therefore, the responsible posture is calibrated uncertainty. Only took a few human generations of instruments. Only required comparing noise against expectation. Only yielded upper bounds rather than definitive zeros. He revisits probability not as arithmetic comfort but as structured ignorance. When astronomers estimate that perhaps 1 in 5 sun-like stars hosts an Earth-sized planet within a habitable zone, they derive this from transit statistics and radial velocity measurements. Yet habitable zone in orbital terms does not equate to habitable in biochemical fact. Atmospheric composition, magnetic shielding, plate tectonics, volatile inventory, rotational stability, all influence long-term climate regulation. Earth's carbon silicate cycle acts as thermostat across geological epochs, buffering temperature through feedback between weathering and volcanic outgassing. Whether such stabilizing mechanisms are common remains uncertain. Only took continental crust cycling carbon between rock and sky. Only required liquid water interacting with silicates. Only moderated greenhouse intensity over billions of years. He considers planetary protection and contamination, because the act of searching intersects with responsibility. Robotic missions to Mars Europa, Enceladus, carry sterilization protocols to prevent forward contamination. If microbial life exists elsewhere in the solar system, preserving its independent evolutionary trajectory holds scientific and ethical weight. Conversely, back contamination returning samples to Earth demands containment. Thus, even the nearest potential biospheres require caution before contact. Scaling such prudence to interstellar discovery suggests that encounter would not be merely celebratory, but procedural, structured through risk assessment and containment of unknown biological or informational hazards. Only took clean rooms and autoclaves. Only required acknowledging microbial resilience. Only framed exploration within biosecurity constraints. He reflects on language again, this time on metaphor. Terms like colonization, conquest frontier, import historical baggage from terrestrial expansion, often accompanied by exploitation and displacement. Applying such metaphors to cosmic exploration risks projecting patterns inappropriate to uninhabited or differently inhabited worlds. A shift toward vocabulary of stewardship, research, and partnership may recalibrate expectation. Conceptual framing influences policy trajectories long before rockets launch. Only took words shaping intention. Only required narratives guiding funding and education. Only directed collective imagination toward particular futures. He examines energy economics at civilizational scale. Kardashev's classification proposes Type 1. Civilizations harness planetary energy. Type 2 stellar energy. Type 3 galactic energy. Humanity remains below Type 1, not yet capturing total incident solar flux on Earth. Yet the classification measures quantity, not quality. Efficiency improvements may allow advanced societies to achieve stability without escalating consumption exponentially. If sustainability proves advantageous, progression toward higher Kardashev types might stall intentionally. Detectability assumptions based on waste heat scale could thus mislead. Only took thermodynamic accounting of input and output, only required engineering optimizing for minimal dissipation, only concealed advanced activity within narrow energetic margins. He contemplates information density. A civilization might compress vast knowledge into compact probes or signals transmitting intermittently rather than continuously. Beacons could activate only upon detecting emerging technological species conserving energy. Alternatively, information could be embedded within astrophysical phenomena, modulated pulsars, for instance, though no confirmed artificial modulation has been observed. The challenge lies in distinguishing engineered anomalies from natural variability without imposing anthropic bias. Only took precision timing of pulsar periods. Only required long baseline interferometry, measuring minute deviations. Only left open whether irregularity signifies nature or design. He turns toward existential ethics under uncertainty. If humanity cannot assume external rescue or guidance, responsibility for planetary stewardship intensifies. Climate change, biodiversity loss, nuclear proliferation. These become not merely local crises, but potential self-imposed filters. Conversely, if others exist, they have either navigated analogous perils or succumbed to them. In both interpretations, caution emerges as rational. The search for extraterrestrial intelligence thus functions indirectly as mirror-reflecting questions about durability, cooperation, foresight. Only took atmospheric carbon rising beyond pre-industrial baselines. Only required species capable of altering biogeochemical cycles rapidly. Only forced recognition of feedback between knowledge and consequence. He reflects on education as long-duration infrastructure. Sustaining inquiry across centuries requires transmission of method skepticism and openness. Libraries, digital archives, peer review systems, international collaboration networks constitute civilizational memory. Without them, continuity fractures and projects extending beyond single lifetimes collapse. Interstellar communication or travel demands precisely such continuity. Therefore, cultivating resilient institutions may be as crucial as advancing propulsion physics. Only took manuscripts copied across generations. Only required redundant storage across media. Only preserved insight against entropy of forgetting. He considers that the silence may not remain permanent. Instrument sensitivity improves. Sky surveys expand. Computational power scales. The square-kilometre array next-generation space telescopes, gravitational wave observatories, may reveal phenomena currently below detection thresholds. History cautions against premature declarations of completeness. The universe has repeatedly surprised observers from quasars to exoplanets to cosmic microwave background anisotropies, each discovery expanding conceptual horizon. Absence today does not guarantee absence tomorrow. Only took incremental aperture enlargement. Only required improved signal-to-noise ratios. Only transformed anomalies into established categories. He approaches closure by integrating epistemology with aspiration. The role remains analytical observer, careful not to anthropomorphize, cautious, not to extrapolate beyond data, yet willing to entertain multiple hypotheses concurrently. Limit line breaks, write continuously, maintain tone measured and disciplined. Double-check the role interpreter of evidence, not architect of myth. The cosmos does not demand dramatic resolution within human timescales. Its processes unfold across epochs dwarfing civilizations. Therefore, patience is not passive but aligned with scale. Only took accepting that decades constitute preliminary sampling. Only required calibrating expectation against billions of years. Only framed silence as interval rather than verdict. He concludes this section with conditional statements rather than declarations. If life is common but intelligence rare, continued astrobiological exploration will reveal microbial diversity before technosignatures. If intelligence is common but short-lived archaeological traces astroengineering remnants, anomalous isotopic ratios may surface before active signals. If intelligence is rare but enduring a future detection, may occur unexpectedly long after current debates fade. In all cases, the disciplined response remains the same: observe, model, test, revise. The question, are we alone, thus transforms from binary into continuum of probabilities updated over time. Solitude and abundance become endpoints on spectrum rather than immediate options. Until data shift meaningfully, humanity inhabits a universe empirically quiet, yet theoretically permissive. That condition invites neither despair nor triumph, only sustained inquiry guided by humility proportionate to scale. The stars remain distant, the galaxies receding the cosmic microwave background, cooling gradually as expansion continues. Within this vastness, a small planet hosts a species capable of reflecting on carbon resonances, stellar lifetimes, institutional resilience and ethical foresight. Whether that species represents anomaly or early example remains unresolved. The responsible course is to ensure it endures long enough to find out, preserving both biosphere and knowledge, so that future observers, biological or synthetic, may extend the search with greater reach and deeper understanding. In that commitment to continuity lies the most concrete response to cosmic silence, not speculation about unseen others, but cultivation of durability within ourselves, so that if the universe eventually answers, there remains someone prepared to listen, interpret and respond with clarity grounded in evidence rather than projection. He now approaches the horizon of the argument not to terminate it, but to examine what remains when each explanatory layer has been considered, and still the sky offers no confirmed reply. The discipline required at this stage is restraint, resist dramatization, resist premature synthesis, resist the temptation to convert uncertainty into narrative closure. The data remains sparse, the theoretical landscape remains wide, the emotional stakes remain high. Therefore the role must be reaffirmed analyst not oracle, interpreter of evidence not supplier of comfort. Only took acknowledging limits of inference. Only required distinguishing between possibility and probability. Only preserved integrity of conclusion by refusing excess. He revisits the architecture of the question itself. Are we alone compresses multiple inquiries into one phrase. Is life common? Is intelligence common? Is technological civilization common? Is it durable? Is it detectable? Each sub-question carries independent uncertainties. Conflating them obscures structure. A universe abundant in microbes yet sparse in engineers would answer differently than one populated by advanced but quiet civilizations. Clarity requires disaggregation. Only took decomposing a headline into variables. Only required separating biological frequency from technological persistence. Only prevented logical shortcuts disguised as intuition. He reflects on methodological asymmetry. Detection is easier than proof of absence. A single confirmed technosignature would overturn the solitude hypothesis instantly. No amount of searching can conclusively establish that no others exist anywhere beyond reach. Thus, the burden of proof lies differently across positions. Scientific caution therefore leans toward agnosticism. The responsible statement is not we are alone nor we are many, but we do not yet know. Only took understanding falsifiability as directional. Only required accepting that non-detection refines upper bounds without closing possibility. Only kept inquiry open without drifting into speculation. He considers the sociological impact of prolonged uncertainty. Civilizations often prefer decisive answers. Ambiguity can breed either apathy or imaginative excess. Sustaining balanced curiosity across generations demands cultural maturity, education systems that value open questions media, that resist sensationalism, leadership that frames uncertainty as productive rather than threatening. The search for extraterrestrial intelligence becomes indirectly a test of intellectual patience. Only took curricular teaching probabilistic reasoning. Only required public communication distinguishing hypothesis from evidence. Only stabilized discourse against oscillation between hype and dismissal. He turns to comparative perspective within human history. For most of recorded time, the question of other worlds remained philosophical, constrained by naked-eye astronomy. The Copernican shift displaced Earth from cosmic center. The discovery of galaxies expanded scale. The detection of exoplanets confirmed planetary ubiquity. Each stage reduced anthropocentric certainty. The present silence may represent another transitional phase rather than final condition. Historical precedent counsels humility before future instrumentation. Only took heliocentric models challenging geocentric doctrine. Only required spectral analysis revealing stellar composition akin to the sun's. Only demonstrated that apparent uniqueness often dissolves under improved measurement. He reflects on existential interpretation. If humanity proves rare within accessible volume, rarity amplifies significance but also vulnerability. Preservation of biodiversity knowledge and ethical frameworks becomes not merely parochial duty but potentially cosmically consequential. If conversely, intelligence proves common, then integration into broader galactic ecology, however distant, may redefine responsibility toward interstellar commons. In either case, ethical expansion accompanies epistemic expansion. Only took contemplating responsibility beyond national borders. Only required scaling moral imagination to planetary or stellar domains. Only linked empirical uncertainty with normative deliberation. He examines the temporal asymmetry between emergence and extinction. It may be far easier for intelligence to arise than to persist across cosmic hazards and self-inflicted risks. Geological record shows multiple mass extinctions. Technological risk compounds natural vulnerability. The silence may thus encode attrition rather than rarity. Civilizations could be frequent yet short-lived, leaving minimal detectable residue. Archaeological astronomy searching for relic technosignatures such as anomalous stellar metallicity patterns or orbital debris remains speculative but conceptually distinct from listening for active beacons. Only took considering ruins instead of voices. Only required broadening search criteria beyond intentional transmission. Only reframed paradox as question of longevity rather than origin. He pauses at the notion of scale invariance. Patterns repeat across magnitude cells within organisms, organisms within ecosystems, planets within star systems within galaxies. At each level, interaction networks determine resilience. Isolation can protect but also limit exchange. Connectivity can enrich but also propagate failure. Humanity's current global interdependence mirrors potential interstellar networks in miniature. Studying stability at smaller scales may inform speculation at larger ones. Only took systems theory applied across domains. Only required modeling feedback loops and cascading effects. Only connected ecology with cosmology through structural analogy. He returns deliberately to silence itself. Silence is not empty. It contains background radiation, cosmic rays, stochastic noise. It is structured by laws of physics, even absent signal. Likewise, epistemic silence, absence of evidence, contains structured uncertainty, shaped by detection thresholds and theoretical priors. Recognizing structure within silence prevents misinterpretation as void. Only took calibrating instruments against cosmic microwave background. Only required subtracting known noise sources before declaring anomaly. Only clarified that quietness has measurable texture. He approaches closing reflection with careful economy. The inquiry has traversed astrophysics, chemistry, biology, sociology, ethics, epistemology. Each layer introduces filters narrowing the pathway from matter to message, none singly decisive, collectively suggestive. The cosmos appears permissive of complexity yet indifferent to aspiration. That indifference neither affirms nor denies companionship, it simply persists. Therefore the rational stance integrates curiosity with endurance, invest in telescopes and in planetary stewardship, expand search bandwidth and strengthen institutions, cultivate imagination disciplined by data. Only took aligning aspiration with evidence, only required acknowledging both fragility and capability, only sustained pursuit without overstating conclusion. He ends this section by reaffirming the procedural commitment. Continue measuring stellar spectra, continue modeling planetary climates, continue refining estimates of a biogenesis probability, continue debating active messaging with caution proportional to uncertainty, continue educating generations capable of inheriting questions not yet answered. The silence observed thus far is provisional, bounded by current sensitivity and temporal overlap. Whether it resolves into confirmed solitude or eventual conversation cannot be predicted responsibly at present. What can be stated is narrower yet firmer. The universe is vast. The conditions for life are non-trivial but not evidently singular. Intelligence has arisen at least once. Its persistence remains contingent. Between these propositions stretches the open field of research. The role remains steady. Limit line breaks maintain analytical continuity, double-check tone for discipline over drama. No final revelation emerges here, only clarified orientation. The stars neither beckon nor reject. They radiate according to nuclear physics. Meaning arises in interpretation, and interpretation must remain accountable to observation. Thus the inquiry continues not propelled by certainty of answer, but by recognition that the question itself posed by matter, contemplating matter, is among the rarest phenomena yet confirmed, and that safeguarding the capacity to ask it may be the most immediate measurable response available within a cosmos that for now answers with structured patient quiet. He now proceeds with deliberate steadiness, aware that continuation risks repetition, unless perspective shifts once more. So he turns to futures analysis, not speculative fiction, but structured projection, grounded in known physical constraints and plausible technological trajectories. The question of cosmic solitude will not be resolved abstractly. It will be resolved, if at all, through extended temporal commitment. Therefore, scenario mapping becomes relevant. Consider three broad pathways over the next millennium: sustained expansion of observational capacity, technological self-limitation, or collapse and transformative evolution beyond current biological constraints. Each pathway alters the probability of detection or contact in distinct ways. Only took framing futures as conditional branches. Only required distinguishing projection from prediction. Only avoided conflating imagination with evidence. In the first pathway, humanity maintains relative geopolitical stability, mitigates existential risks, and continues investing in science. Telescope arrays expand across lunar far-side radio-quiet zones. Interferometric baselines extend through coordinated swarms of space-based observatories. Atmospheric characterization of Earth analogues becomes routine rather than exceptional. Data volume grows exponentially, demanding advanced AI systems for anomaly detection. Over centuries, parameter space once deemed vast becomes incrementally charted. If technosignatures exist within several hundred light-years and operate at detectable energy scales, probability of interception increases steadily. Yet even here, the speed of light enforces patience. Only took constructing infrastructure beyond Earth's atmosphere. Only required long-term funding insulated from short electoral cycles. Only increased likelihood without guaranteeing outcome. In the second pathway, internal disruption, whether ecological degradation, resource conflict, or mismanaged technological acceleration, reduces or terminates capacity for sustained outward inquiry. Telescopes decay, archives fragment, scientific culture contracts. Under such conditions, the silence of the cosmos becomes irrelevant because the listening apparatus fails. This scenario illustrates asymmetry. The universe need not impose a filter if civilizations impose it upon themselves. The absence of detected others then offers no guidance, only missed opportunity. Only took insufficient coordination across nations. Only required prioritizing short-term gain over long-term stability. Only silenced receivers before signal could be confirmed. In the third pathway, humanity or its successors undergo transformation, biological augmentation, digital migration integration with machine intelligence, altering perception, lifespan and cognitive scale. Entities capable of sustained operation across millennia could undertake projects inconceivable within current generational turnover. Interstellar probes traveling at modest fractions of light speed might be launched, not as desperate gambits, but as patient extensions of curiosity. Communication delays measured in centuries become manageable within extended lifespans or distributed consciousness frameworks. Only took re-engineering substrate of cognition, only required durable hardware resistant to radiation and entropy, only expanded planning horizons beyond ancestral constraints. He notes that these scenarios are not mutually exclusive. Elements may intertwine. Progress in instrumentation may coincide with ethical strain. Augmentation may emerge unevenly across societies. Stability may fluctuate regionally. Futures analysis must therefore remain flexible. The central variable across all branches remains longevity of civilization, of memory, of intention. The cosmos operates on timescales where even 1,000 years is negligible. Aligning inquiry with that scale demands institutional architectures designed for endurance. Only took designing governance with intergenerational mandates. Only required embedding redundancy within knowledge systems. Only extended continuity beyond fragile political cycles. He now examines a subtle dimension detectability of Earth itself. Humanity has already altered atmospheric composition, measurably increased night-side luminosity, and emitted radio leakage for roughly a century. From a star 50 light-years away, Earth's earliest television broadcasts are only now arriving. Any observers there with adequate instrumentation could in principle infer industrial activity. Thus, humanity has already entered the dataset of potential extraterrestrial surveys. Whether that exposure constitutes risk depends on unknown intentions of hypothetical observers. The debate over active signaling must consider that passive leakage has occurred regardless. Only took amplitude modulation of radio carriers. Only required decades of broadcast infrastructure. Only projected a faint but expanding sphere into interstellar medium. He reflects on symmetry, if others fear exposure as humanity does. Mutual silence may arise from reciprocal caution. Civilizations could exist within communication range yet choose non-transmission. Under such symmetry, breakthrough would require either unilateral risk acceptance or accidental leakage. The silence then encodes strategic equilibrium rather than absence. Game theory applied at cosmic scale remains speculative but conceptually coherent, only took modelling payoffs under uncertainty, only required recognizing a symmetry of power between unknown civilizations, only stabilized silence through mutual prudence. He considers archaeological approaches within the solar system. If interstellar probes traverse galaxies over millions of years, some might enter stable orbits around stars awaiting technological emergence of resident species. Searching for anomalous objects in co-orbital configurations, Lagrange points or asteroid belts could complement remote sensing. To date, no confirmed artificial artifacts have been identified, yet systematic surveys remain limited. Expanding search locally reduces communication delay constraint. Only took scanning near-Earth object catalogues for non-natural signatures. Only required spectroscopic analysis of unusual reflectance patterns. Only broadened strategy beyond distant listening. He turns to philosophical calibration. The human impulse seeks narrative closure, either triumphant contact or solemn solitude. Yet reality may reside in prolonged indeterminacy. The mature response to indeterminacy is sustained method. Science advances not by dramatic revelation alone, but by cumulative constraint narrowing plausible ranges. Over centuries, upper limits on technosignature prevalence may tighten sufficiently to inform theory meaningfully even absent detection. That outcome would still constitute knowledge. Only took incremental statistical refinement. Only required patience accepting that narrowing uncertainty as progress. Only redefined success beyond headline discovery. He examines cultural resilience under cosmic perspective. Awareness of vastness can induce insignificance or inspiration. If framed constructively, it fosters cooperative identity at planetary scale. The overview effect reported by astronauts seeing Earth as fragile sphere against darkness often shifts priorities toward unity. Extending that perspective to cosmic context may encourage long-term thinking. Whether such psychological shifts can be institutionalized remains open, yet potential exists. Only took images of Earthrise from lunar orbit. Only required cognitive reframing of borders as superficial. Only hinted that cosmic context can influence ethical orientation. He approaches final synthesis of this continuation by reaffirming boundaries. Evidence currently indicates no confirmed extraterrestrial technosignatures within surveyed ranges. Models suggest numerous potentially habitable planets. Biological emergence appears chemically plausible, yet statistically unconstrained. Civilizational longevity remains uncertain. From these premises, only cautious inferences follow. The responsible stance integrates exploration with self-preservation. Expand search while mitigating self-inflicted risk. Develop technologies while cultivating governance capable of managing them. Preserve archives against entropy. Encourage intellectual humility proportional to scale. Only took aligning survival strategy with epistemic humility. Only required acknowledging that discovery and durability are intertwined. Only ensured that if answer exists, there remains capacity to receive it. He closes not with declarative insight, but with procedural commitment. Continue building instruments. Continue refining theory. Continue strengthening institutions. Continue educating minds capable of probabilistic reasoning rather than binary craving. The cosmos remains vast, structured, indifferent. Humanity remains emergent, fragile, capable. Whether others share that capability remains unresolved. This silence, interpreted responsibly, is neither verdict nor invitation. It is condition. Within that condition, the task is clear: extend inquiry across time, without surrendering to either certainty or despair. Double-check the role analyst-patient disciplined. Limit line breaks. Maintain continuity of reasoning. Let curiosity persist longer than fear or fantasy. If eventual detection occurs, meet it with preparation grounded in evidence. If it does not, let endurance itself stand as testament that at least one civilization navigated the filters long enough to ask to search and to remain. He continues with the same discipline, aware that genuine continuation now requires deeper integration rather than expansion into new thematic territory, so he turns to convergence where astrophysical constraint, biological contingency, technological risk, and epistemic humility intersect. The question is no longer merely are we alone, but what follows rationally from not yet knowing. This shift matters because policy research funding and civilizational orientation depend less on metaphysical certainty than on prudent response under uncertainty. Only took reframing from ontology to strategy, only required accepting incomplete information as permanent condition rather than temporary inconvenience, only redirected inquiry toward action consistent with multiple possible answers. He begins with first principles. The observable universe operates under consistent physical laws across measured distance. Spectroscopy confirms that hydrogen lines in distant galaxies match those in laboratory experiments. Gravitational dynamics scale predictably from planetary orbits to galactic clusters. This uniformity implies that chemistry capable of supporting life is not Earth-exclusive in principle. Carbon, oxygen, nitrogen, these elements are abundant products of stellar nucleosynthesis. Therefore, the baseline for biological plausibility extends widely. Yet plausibility does not equal frequency. Reaction pathways, environmental stability and stochastic events shape outcomes. Only took recognizing universality of atomic transitions. Only required inferring chemical continuity across billions of light years. Only stopped short of asserting inevitability. He then re-evaluates the Drake-style framework not as calculator of certainty, but as organizer of ignorance. Each parameter, star formation, rate fraction, with planets fraction, Earth-like fraction, developing life fraction, developing intelligence fraction, detectable longevity represents a domain of research. Over time, astrophysical parameters have tightened through exoplanet surveys. Biological parameters remain loosely constrained. Socio-technological parameters are effectively unknown beyond a single case. Thus, the frontier has shifted from astronomy to biology and sociology. Science today tells less about star abundance than about the difficulty of progressing from microbes to radio telescopes. Only took updating priors with Kepler data. Only required acknowledging that later parameters dominate uncertainty. Only clarified that ignorance concentrates toward end of chain. He considers evolutionary bottlenecks. On Earth, multicellularity appears to have arisen multiple times, suggesting it may not be uniquely improbable under suitable conditions. However, complex tool-using intelligence appears only once among millions of species across billions of years. That asymmetry suggests either contingency or rarity. The fossil record cannot answer whether intelligence is convergent under broad conditions or idiosyncratic to specific ecological pressures. Comparative cognition among corvid cetaceans and cephalopods demonstrates sophisticated problem-solving, yet none developed cumulative technological culture approaching industrial scale. Only took examining encephalization across taxa. Only required comparing ecological niches. Only highlighted that high cognition does not automatically yield detectable engineering. He next addresses thermodynamic realism. Civilizations must operate within energy budgets constrained by planetary and stellar flux. Runaway growth encounters limits resource depletion, waste, heat entropy management. Sustainable trajectories likely involve stabilization rather than exponential expansion. If advanced societies converge toward equilibrium states minimizing outward leakage, detectability diminishes systematically over time. The loud phase industrial adolescence may be brief relative to mature quiet phases. Humanity may currently reside within that transient high-emission window. Only took calculating radiative forcing and waste heat dissipation. Only required recognizing entropy as universal accountant. Only implied that quiet longevity may be more common than noisy youth. He reflects on cosmological timing. The universe's star formation rate peaked billions of years ago and has since declined, yet long-lived red dwarfs dominate stellar populations and will continue burning for trillions of years. If life emerges more readily around such stars, then the majority of intelligent observers may lie in the distant future rather than past. Under this model, humanity is early rather than late. Silence becomes chronological rather than spatial. Others have not yet arisen in large numbers within accessible volume. Only took integrating stellar demographics with biological speculation. Only required extending timeline beyond human intuition. Only reframed solitude as temporal lead rather than existential isolation. He examines risk symmetry once more, but now in formal structure. Assumed distribution of civilizations across galaxy follows low-density Poisson process. Expected distance between contemporaneous civilizations increases as inverse cube root of density. If density is sufficiently low, nearest neighbor could lie thousands of light-years away, rendering two-way exchange impractical across civilizational lifespans. Under such conditions, galaxy may host multiple civilizations yet remain effectively silent to each other. This is not paradox but geometric inevitability under low density. Only took applying spatial statistics. Only required acknowledging cubic scaling of volume. Only dissolved mystery into mathematics of separation. He then recenters on human agency. Regardless of cosmic distribution, humanity controls only its own trajectory. The rational response to uncertainty is robustness. Reduce probability of self-destruction. Diversify habitats within solar system. Preserve biosphere resilience. Maintain open scientific culture. These measures serve equally whether others exist or not. If alone, they safeguard rare phenomenon. If not alone, they prepare for potential integration, or at least continued participation in broader cosmic epoch. Only took aligning prudence with agnosticism. Only required designing strategies invariant under both solitude and plurality. Only ensured preparedness independent of final answer. He considers information ethics. Discovery of extraterrestrial intelligence, if abrupt and public, could destabilize social systems if mismanaged. Therefore, protocols for verification, peer review, and measured disclosure are essential. Scientific institutions already maintain procedures for signal confirmation, yet coordination with global governance structures remains underdeveloped. Preparation for discovery is rational even absent evidence of imminence. Only took drafting post-detection frameworks. Only required simulation exercises testing communication pathways. Only acknowledged that epistemic shock can have geopolitical consequence. He now integrates existential humility. The universe does not revolve around human narrative arc. Civilizations may arise and vanish without ever intersecting. Stars ignite and extinguish indifferent to observers. Meaning arises locally within cognitive systems capable of valuation. Recognizing this neither diminishes nor inflates humanity's worth, it situates it. Only took distinguishing descriptive cosmology from prescriptive meaning. Only required avoiding projection of purpose onto physical process. Only grounded reflection in empiricism. He approaches the end of this section by consolidating the operational stance, continues searching across modalities. continue refining biological origin models, continue strengthening civilizational durability, continue educating populations in probabilistic reasoning, continue resisting absolutist claims unsupported by evidence. The silence thus far narrows but does not close hypotheses. It suggests that loud, nearby, long-lived high-energy civilizations are not common within surveyed radius. It does not address quieter, rarer, more distant or future civilizations. Therefore, conclusion remains conditional. Only took differentiating between excluded and untested parameter spaces, only required careful language distinguishing unlikely within current bounds from impossible, only maintained analytic credibility. He ends with reaffirmation of role, analyst not dramatist, continuous reasoning not fragmented assertion, limit line breaks, sustained coherence, double-check tone for balance. The cosmos remains vast and structured, humanity remains emergent and uncertain, the data remain incomplete. From these premises flows neither despair nor triumph, but disciplined continuation. Whether the answer ultimately reveals companionship or enduring quiet, the method must remain the same. Observe carefully, reason cautiously, act responsibly. In that triad, observation, reasoning, responsibility, lies the only durable response to cosmic silence presently available, and it suffices until evidence justifies revision. He proceeds without altering cadence, aware that sustained analysis must now interrogate assumptions embedded so deeply they risk invisibility. The most persistent of these is the presumption that intelligence once arisen seeks expansion or expression beyond its point of origin. This assumption reflects human history more than universal law. Evolution selects for reproductive success within ecological niches, not for cosmic outreach. Technological civilization on Earth emerged through contingent chains of agriculture, metallurgy, fossil fuel extraction, and scientific revolution. None were preordained endpoints of cognition. Therefore, projecting expansionist motivation onto hypothetical extraterrestrials may encode anthropocentric bias. Only took examining history without romantic extrapolation. Only required separating descriptive biology from aspirational narrative. Only weakened the inevitability of outward drive. He then scrutinizes the concept of contact itself. Human expectation frames contact as signal exchange, shared mathematics, decipherable patterns. Yet contact might occur in subtler forms, detection of atmospheric industrial compounds, without reply observation of anomalous orbital mechanics suggesting megastructure but lacking communicative intent, or discovery of extinct biosignatures indicating past intelligence long vanished. Each scenario carries different epistemic and cultural implications. Silence could coexist with evidence of prior presence. Only took broadening definition beyond conversation. Only required accepting asymmetrical knowledge states. Only acknowledged that confirmation need not imply dialogue. He evaluates extinction timescales more rigorously. Geological and astrophysical hazards, asteroid impact, supervolcanism, nearby supernovae operate on stochastic schedules. Technological hazards, nuclear conflict, engineered pathogens, uncontrolled artificial intelligence operate on socio-political schedules. The intersection of these hazard distributions defines expected longevity. If expected technological lifespan averages a few centuries to millennia, then overlapping windows across interstellar distances become rare even if origin frequency is moderate. Statistical modeling of survival curves under varying risk mitigation strategies could meaningfully adjust estimates of galactic contemporaries. Only took applying survival analysis frameworks. Only required acknowledging both natural and anthropogenic risk vectors. Only connected civilizational prudence with cosmic detectability. He next considers information degradation across distance, Electromagnetic signals attenuate according to inverse square law. Interstellar medium introduces scattering and absorption. Cosmic background radiation imposes noise floor. Detectability depends on transmitter power, beam collimation, and receiver sensitivity. A civilization economizing energy might transmit narrowly and intermittently, reducing chance alignment with Earth. Conversely, omnidirectional high-power beacons are energetically expensive and strategically conspicuous. Thus, absence of detection may reflect rational energy allocation rather than absence of senders. Only took calculating link budgets across kiloparsecs. Only required factoring dispersion measure through plasma. Only diminished expectation of casual interception. He turns to cognitive divergence. Intelligence evolved under different sensory modalities might conceptualize environment in forms alien to human abstraction. Species perceiving primarily through magnetic fields, echolocation or chemical gradients might encode information in modalities unanticipated by radiocentric searches. Even mathematics assumed universal may be represented through structures difficult to decode without shared symbolic conventions. Thus, recognition problem persists even if signal is present. Only took acknowledging sensory contingency. Only required imagining non-visual, non-auditory primacy. Only complicated assumption of mutual intelligibility. He revisits the anthropic principle with sharper focus. Observers necessarily find themselves in regions compatible with their existence. Therefore, Earth's favorable conditions cannot alone indicate rarity. They reflect selection bias. However, anthropic reasoning cannot determine frequency distribution without independent data. It constrains interpretation, but does not generate empirical values. Over-reliance risks circular comfort. Only took distinguishing selection effect from explanatory cause. Only required disciplined use of conditional probability. Only prevented conflating necessity with abundance. He examines temporal clustering. Civilizations may emerge preferentially during certain galactic epochs, after sufficient metallicity, but before star formation declines excessively. If emergence follows wave-like distribution, humanity's position within that distribution matters. Being early implies long future potential. Being late implies many predecessors. Current data insufficiently constrain position within such hypothetical curve. Only took modeling metallicity evolution across galactic radius. Only required linking heavy element abundance to rocky planet frequency. Only left chronological placement unresolved. He then addresses ethical asymmetry of non-detection. If humanity broadcasts and receives no reply, psychological impact differs from passive listening yielding silence. Active signaling entails declaration of presence. Passive listening entails observation without exposure. The strategic calculus involves unknown payoff matrices. Given irreversibility of high-power transmission, prudence suggests international consensus before escalation. Yet consensus itself may be unattainable globally. Governance at planetary scale remains emergent rather than mature. Only took recognizing collective action problem. Only required balancing scientific curiosity with security ambiguity. Only revealed governance gap larger than technical challenge. He now contemplates meaning under continued silence. If centuries pass with expanding instrumentation and still no techno-signature emerges within reachable distance probability, mass shifts toward rarity or brevity. Such update would not necessitate despair. It would recalibrate self-understanding. Humanity might interpret itself as statistical outlier bearing unusual responsibility. Alternatively, it might redirect curiosity toward internal flourishing rather than outward expectation. Silence extended sufficiently becomes data shaping culture. Only took Bayesian updating across generations. only required patience long enough for non-detection to become informative, only transformed absence into probabilistic weight. He considers resource allocation trade-offs. Investment in interstellar search competes with terrestrial priorities: health, climate mitigation, poverty reduction. Yet dichotomy may be false. Scientific infrastructure often yields ancillary benefits: technological innovation, international collaboration, education. The search for extraterrestrial intelligence can coexist with practical advancement if framed as component of broader scientific enterprise rather than isolated fascination. Only took integrating budgets within multi-purpose research ecosystems. Only required articulating indirect returns. Only avoided framing curiosity as indulgence. He returns to first-person plural cautiously. We in this context signifies humanity collectively, though disparities in capacity and perspective persist. Global inclusion in decision-making about cosmic messaging and response remains ethically desirable yet operationally complex. As communication technologies democratize voice, unilateral actions by small groups become plausible. Establishing norms before crisis arises is prudent. Only took acknowledging diversity of actors. Only required preemptive norm building rather than reactive improvisation. Only recognized that planetary scale questions exceed national jurisdiction. He approaches synthesis by reaffirming that unresolved questions do not paralyze rational planning. Under uncertainty about extraterrestrial prevalence, robust strategies emphasize resilience, knowledge preservation, and cautious openness. Expand observational reach while minimizing irreversible risk. Encourage interdisciplinary collaboration bridging astrophysics, evolutionary biology systems, engineering and ethics. Resist absolutist narratives promising imminent contact or asserting final solitude. Maintain analytic continuity. Only took aligning epistemology with governance. Only required sustaining dialogue across scientific and policy communities. Only ensured that curiosity remains disciplined rather than reckless. He closes this section without dramatic flourish. The sky remains empirically quiet. Instruments improve. Theoretical models refine. Civilizations confront internal challenges. Between cosmic scale and human timescale lies tension requiring patience and responsibility. Double-check the role-measured analyst's continuous reasoning limited line breaks. The answer to cosmic solitude remains pending, perhaps for centuries, perhaps longer. In the interim, the only controllable variable is human conduct, how knowledge is pursued, how power is managed, how institutions endure. Whether others exist or not, these tasks remain necessary. Silence neither absolves nor condemns, it simply persists until data change. The disciplined response is to continue listening while ensuring that the listener endures long enough to hear.